All right.
Hello. All right, I'm going to put you back on the screen. And so in about 2 minutes, it should automatically go live. And if it's not clear to you when that happens, then I'll let you know. And then we'll just wait a couple minutes and see how people join and if there are any challenges that anyone has, and then we'll proceed. Sound good? All right.
Yeah, sounds good. So if I put something in the chat right now, would people joining later see it? Ooh, I
don't know. Try it. We get to figure it out. So go for it.
I can hear myself.
Oh. Yeah, you may want to mute.
With a delay of like 10 seconds.
Yeah. Ooh, that's hard. And unfortunately, I can't hear you though. Yes.
So this wasn't a problem before.
No, it wasn't. Try rejoining. Try exiting and then rejoin.
I know what happened. I have the YouTube open, which is now just streaming what's happening, but with a delay. So if I close that or mute that, then it's all fine. Yes, okay, we're good.
Robin has just tried to connect using the link, the StreamYard link, and not the other one. Hello, Robin.
Hey, hello. Can you hear me?
We can.
Hello. Hi, yeah, we can hear you.
Oh, she went away. Let's try that again.
I'm trying to.
Yes, hi.
Robin. You're right now connecting with the StreamYard link, and I'm wondering if you can try connecting perhaps with the LinkedIn link or the YouTube link, if you have either of those.
I will give it a try.
Yeah, I put them in the chat.
Okay.
Thank you.
I'm going to remove her from the stage. And Noel just sent a note saying it looks good. I guess he's now connected.
Oh, that's nice. I know. Very interesting, one-sided way of
So for those of you who are connected and waiting for amazing things to happen, Julia and I decided just to wait for about 5 minutes before we begin so that everyone has a chance to connect and figure things out. And I'm sure I'll repeat myself in a couple minutes here. I just saw that comment you posted, Julia. I'm excited to figure out what else this tool does beyond what I've already done. Robin is here, trying to connect again. Let's see here. I'm going to pull them in. Well, I'm not able to add Robin. And something I mentioned earlier is we're going to wait until 5 minutes after the hour before we begin so that everyone has a chance to connect and figure out this new tool. If you have any questions, email or direct your questions to Julia and she can answer them. And if you happen to be connecting to the StreamYard link, you'll find that it might be a bit confusing because that link tries to enter you onto the stage here. Whereas if you'd just like to post questions and see the live stream, it's preferred that you use the YouTube link or the LinkedIn link. And if you don't know what those are, send Julia a message or Robin a message. So if you had to choose what sort of music to listen to for the next minute, what would it be, Julia?
Yeah, maybe something AI generated. That would be very much in tune with today's topic. Can't you do that yet? To just ask Claude or ChatGPT, can you generate some lobby music for me for 1 minute?
I tried that once and it was terrible. This was about a month ago. I'm sure things have changed. Yeah, but
yes.
Right now I'm thinking something from Freddie Mercury or Queen.
Wow, sure, I'm down for that.
Maybe cool. Right after. No, okay.
What would be your favorite song?
For some reason, the song "Another One Bites the Dust" is in my mind.
Wow. Is this foreshadowing anything happening in the
I know, right?
Oh, exciting.
Okay. And is anyone able to join on LinkedIn? When I try,
I see there are 9 people watching.
Okay.
So...
On LinkedIn?
Yes.
Okay.
No, that's YouTube. Sorry, my bad.
That's YouTube. Okay. All right. Well, I've got this weird thing on LinkedIn saying that, well, I can't join remotely. So if anyone is on LinkedIn trying to join, I guess they won't know this, to use the YouTube link. So I'm just going to type in the YouTube link into the chat, and then we'll start going.
Yeah, because the LinkedIn tells me that it's starting soon. I don't know if that's just me.
Yeah. Okay. One more moment.
Yeah, Don't Stop Me Now is also great.
Yeah. Yep. Yep.
So yeah, I think we can just start whenever you are ready.
Okay. Okay, well, here we go. So some background. About a month ago, I was introduced to Julia and her team. And we decided to put together a presentation. So I'm going to pass this on to Julia and let her do a little introduction and background, and then I'll jump in when she's done.
Yes, thanks, Philip. Hi, everybody. Very happy to see people here joining from the Utrecht Inc., but also from the UMC Utrecht, part of our team. But whoever is here, Noel is also here. We very happy to have you on board. So I have the honor of introducing Philip, telling you a little bit of who he is. So Philip is a senior developer who works a lot on machine learning and signal processing. So he's had a lot of experience in these areas, applied specifically to biomedical applications, and he's expanding currently, as far as I understood, to also diagnostics and some predictive intelligence there. So he's got a ton of experience doing that firsthand as an engineer himself. But obviously, like many of us, has noticed over the past several years that there is a surge of AI, and these methods and these agents are becoming better and better at helping us write code, create codes, do all kinds of analysis. So he now calls them his AI colleagues, and he's now had ample experience, particularly with Claude and Gemini. And he suggested to kindly share his experiences and what works well with these tools applied to these questions, what you should be careful about, what is basically the good practices, the good, the bad, and the ugly of that experience. So we have to welcome him to the stage and tell us everything he knows. And please, for those in the audience, do share your questions. You can post them in the chat on YouTube or on LinkedIn if that works for you. I will pass them on to Philip at the end of his talk so we can jump into questions there. Does that sound good?
Yeah, thank you, Julia.
And
given that we have limited time, of course, I had to curate things as much as possible to create an understandable narrative here and also answer some questions. And so the goal is for this to be introductory, so that we can speak with one another and just kind of feel things out. And then certainly we can carry conversations beyond this presentation here. Now it's about 10 minutes after the hour. I haven't timed this presentation yet, but I know that it's your workday right now. So I'll be conscious of that and considerate of that. And so we won't go more than another 45, 50 minutes here. Now, let's proceed. Okay, next slide. So a little bit about me, for those of you who don't yet know. I'm right now calling in from Vancouver Island on the west coast of Canada. If you can see on that map there, most of you are in the Netherlands, quite a distance away. So there is a time zone difference. That's why it's so dark in here. My background, I was originally trained as an engineer, specializing in building computers. computer engineer, and then I sort of did a side specialty in signal processing. I did that at the University of Victoria. And then after my undergrad, I went and did product design in San Francisco. And you'll see why that product design streak is relevant as we go further into the talk. After doing product design, I came back to Victoria and trained as a scientist and did a PhD there that covered brain-computer interface technology at the time, engineering, experimental psychology, and neurobiology. I really liked trying all of the things. And after that, I made an attempt to bring to market the things that I created in my PhD, but that was a terrible failure, and I felt horrible. And then I learned that was a really good thing to have failed at a startup, and I got to join a club, and everyone was like, "Yay!" And part of my sort of eloquent extraction from the startup world was becoming a dad, and I got my first job and continued from there. But since then, for the last 12 years, I've been helping companies build products. And so I've had many titles. One of the most recent ones was a product-focused senior R&D scientist, whatever that is. And I've worked with people all over the place in Denmark, the Netherlands, United States, and Canada. And if you would like to know more about me, I posted my website there on the bottom. Now, the last 12 years has been very much a story of improving, figuring out what this art is called algorithm and signal processing development, product development. And last year, I did a presentation. The date on that was October 29. And I was ready to share everything that I've learned not to do and to do. And this was, I was ready for this because I did my first project in 6 months, where we went from just having a small bit of idea and proof of concept, essentially what would have been done in a university, to bringing something to a first prototype, where we can say, okay, this is going to work in the real world, it's feasible. And we did that in 6 months, and that included in vitro work, in vivo work, creating study protocols, actually measuring and collecting data subcutaneously from an animal model, and creating a pipeline where we could analyze multiple data sets using a V1 algorithm in a short amount of time. And I thought, okay, awesome, 6 months. I have something I can offer to people, a package. And so I described that fairly specifically with specific steps. And of course, there are always things that I would run into when working with different companies. Early stage companies, I learned, try to get everyone to focus on very specific things and not other things. And there's not always clear understanding about what's important. And so what I found with many early stage companies building products was we would have an initial prototype device, and then we would do data collection, and then we would analyze those data, and then we would try to create an algorithm around it. We would figure out that maybe the data are too noisy, or there are some challenges with the data. We go back and collect data. And one of the places where we would always lose the time is that loop of collecting data, analyzing the data after the fact, and going back to collect more data. Often it seemed to me very important to just get the data quality analysis the moment the data are collected, but often that was discouraged as not priority, because we'd have to build a GUI or a real-time system or something like that around that. other things that came up over the years, that ultimately fed into this 6-month solution, were the discouraged activities that I encountered from various CEOs, which was focus on the real data, don't do synthetic data modeling, and don't do simulations. Other requested activities were create beautiful plots or export data to other formats so they could look at the data themselves. And that added more challenge to things. And so I have comment about those things, about what would be the ideal process. And then I also noticed that different companies have different processes for in vitro and in vivo analysis and reporting. So that always has to be worked out. And what always came to my mind, as a result of my training in engineering school, was one of my professors, Stephen Neville. Always test your code with synthetic data and modeling and simulations, right? And meanwhile, in these real world applications and startups, it's just sort of, okay, you get the data, analyze the data, right? So there's always pushback there because these synthetic data and modeling and simulations take time. So this loop, this frustrating loop of starting a project, deferring some real-time analysis, but collecting data, finding sort of problematic things at the desk, and then going back to data collection, became a loop and a theme. And so what I've always wanted was to get away from that. And I would say I'm never doing that again, but then it would happen. So what I learned to do was create some policies and procedures for myself, and pledged to myself to push back to clients and say, no, we have to do these models, we have to do these simulations. And when things would go wrong, when things we'd encounter bumps, I can pretty much always pin it down to a moment where I wasn't clear about the process, or we didn't have a clear process, and we didn't stick to our policies. And so, another colleague of mine and mentor, Glenn Hallam, I always have this voice in my head, is that processes keep people safe. So when something doesn't go quite right, if we know that people followed the process, then we would assign the blame, the correction to the process, not the person. Let's see if I stated that correctly. It's early in the morning here. When things go wrong, we want to be able to blame and correct the process and not pin it on the person. And so there's a picture of Glenn. I grabbed his photo from LinkedIn just to sort of honor that. That voice is always in my head. There's another thing I learned from Glenn, and is a part of my policy and process, which is to never put brand new plots or results in front of stakeholders, not until kind of we've looked at them for a few days and we understand what's there and the issues. That said, when I break my policies and processes, things like that happen. So now we're in this new world of generative AI compared to last year, right, when I created this 6-month process. And the new story is what's happening, what's going on, who's doing what should we do? And I'm sure many of you have had these similar experiences as I have, which is working with ChatGPT when it came out, that I would ask it questions and it would agree with me. There was this sycophant, I think is the popular word of the year here for various reasons. But similar to Gemini has become very difficult for me to work with because it keeps telling me how insightful I am when I'm trying to be a critical thinker and I'm trying to get some objective information. But also something to note about Gemini specifically is what I've been noticing is it hallucinates whenever I work with a particular chat long enough, whether it's going over some sort of analytical problem, or whether I'm using it to code something, which is why I sort of decided to try Claude. I had heard that maybe this will help. And well, the funny thing with Claude is it has an accent, at least from my perspective, and it's quite comical. So this new world of generative AI, there are a lot of aspects to it, and for our purpose, it's important to narrow it down so that we just know what we're going to be talking about and discussing here, which is we're going to focus specifically on large language model coding tools. Okay, and specifically, I'm going to be looking at Claude. And we're also going to be looking at the large language model, large language coding tools in product development, or as part of a product development process. And so that includes all of these things: the GUI prototypes, coding assistance, strategy formulation, analysis of data, and doing algorithms, documentation, or a collaborative process. So, for example, when I'm stuck, can I collaborate with this thing? And one of the, again, lessons I learned in this new world of what the heck is happening, my friend Polly, who worked with Amazon for a bunch of years, told me, Phil, just start building things. Just build prototypes, and then it'll become clear. So I started doing that. And I built a typing tutor for my kids. That was one of the first ones using Claude Code. My 9-year-old daughter and I sat down. We scanned some pictures that she had drawn of cats. And I just dumped those image files into the Claude terminal. And it created renditions of that. It could see those images and do something with it. And we created this sort of gamified typing tutor. And then for my son, he didn't want to learn how to type properly. He wanted to do this, to type like Noel does. Sorry, Noel. I don't know how he still does that. But I added some features where it times the key presses for the left and right hand. It looks at to see if there's a normal or Gaussian distribution for his typing time. To try and detect when he was not using proper typing technique, and that was fun. I built a software, I guess we call them software or apps, to help with strategic decision making and problem statement redefinition. And then about a week ago, I built I guess we call it a program. I talked to Claude. I gave it a bunch of PDF files for my year-end, my corporate year-end, and invoices and such. And it behaved like a bookkeeper and created, did all the account reconciliation and created sort of a report for my accountant. And then I thought, okay, let's try something a little more complicated. So I built call it an edge computing client server system that analyzes engine acoustics to try and figure out faults or look for problems. So I was able to find imbalances between different cylinders in my Nissan Xterra. And then I tried some other things. But the point is this. I learned how to use it by just trying to do some simple projects. And this is what the Claude terminal looks like. And this is sort of my preferred space. I understand there's some GUI component to Claude and various plugins, but I've been able to do everything through just this terminal interface here. So I had an epiphany going through this, and Julia mentioned the words, I think it was AI collaborator at the beginning of the presentation. And the epiphany came this way, is after doing just coding Okay, so sort of journey with me to this moment when I've just been asking it to write code. I've been telling it how to do things. And every once in a while asking for some input. But the epiphany was this. I asked it about working agreements. I said, do you know what a working agreement is? Tell me what you think it is. And Claude responded. And this idea came from working with other development teams using Scrum and Agile methods. And in those teams, we would create a working agreement so that we would get along and we could be productive together. And so I asked another question. For our purpose, which of these items that described, what a working agreement is, what pertains to us, what's useful based on what we've done together already. And by the way, I started this sort of introspective process or this retrospective process with the AI after having worked a week on a biomedical application. And I wanted to know what was working and what wasn't effectively. And it gave me feedback. These what I've posted on the screen are the strongly relevant things. Talking about concepts of definition of done. We talking about generating PDF and documentation when we do each of our steps. Talking about the use of our synthetic data. Talking about I had introduced the AI, the concept of stakeholders. Like we have to create a plot for investors. What would that plot be? What I learned was that I could very much collaborate with this thing. And then I asked it more questions, critique what I've done and tell me how I can improve. And I laughed at the response because this is something I had heard a couple of years previous. The Claude told me my code was a dumpster fire. And I agree. It is. When I'm doing experiments, I don't like to delete things. I like to just create multiple versions of this thing until I get something that works, because I like to cut and paste my code and whatnot. And I came up in the engineering pedigree and not in the computer science pedigree. And I know that we do things a little bit differently than one another. So I get that. And it's funny to me. But Noel, surprise Noel, had told me my code was a dumpster fire years before Claude did. And this also reminded me that who built Claude and what Claude was designed to do. Claude probably has a computer science pedigree and not an engineering pedigree, if I think about it here. So thank you, Noel. My code is still a dumpster fire. But going back to this epiphany is about rules and processes. Is that we can create a set of rules to follow. We create a process. People need processes to keep them safe. The AI needs processes. And we can figure out and create those for the AI so that it stays on track. It has this thing called a memory file. Claude does readme.md or various readmes. And it stores things in long-term memory. So what I realized is as I was using Claude, it was learning my behavior. And it was learning the important things about how I work as a senior product R&D scientist. And what I learned was that I could give it specific processes to follow that would keep us from doing silly things, or keep me from doing silly things. Now, one of the important things here, and this is going to come up a bit later, is I've been referring to Claude as a person a little bit. I've been using the word we when I describe working with Claude. one of the nuances in all of this is if I deliver some work, even though I've followed my process, I've looked at things, like this question of who did the work. Was it Claude or was it me? And I realized the important distinction was, if I can't say that I did it, that probably means that I don't understand it and I shouldn't make it my final deliverable. Because ultimately, I'm the person responsible for this. So there's some policies with these memory files and whatnot that a person can create to help people like me from making that mistake and delivering things that the AI did that I don't fully understand. So back to this idea of creating processes. So we create processes for humans to follow, right? And we can do that for use of AI. We can say use AI for creating only this specific type of code. Maybe it's just figures, maybe it's just the GUI and whatnot. Maybe we can create a process or policy for us humans that we only allow AI to touch an alpha code base. Or keep a list of functions that the AI has touched. But what's really important is to keep the peer review process in place before we can consider the AI code as correct. Now, having said that, we can also create processes and policies for the AI itself. And this is some of the learning that I experienced while working with Claude on some of these other projects, which is to always create paired synthetic data based on physics theories with my real data. Run synthetic data on the code before running the real data. Maybe even plot the synthetic data and the real data on top of one another so that we can compare them. Right? All of a sudden, this opens up this ability to use engineering models, signal plus noise models, however you want to model those things, with math equations or synthetic data. We can pair those on top of each other. So this is something I would have loved to do last year, but we just didn't have time to do these things. And now we can do them much faster. Also, look the plotting residuals and things that don't quite fit, our real data versus our synthetic data. That all of these things are useful to catch errors and to discover new things. Following processes. Okay, that's sort of my third point here, which is, again, this is my learning, expressing to everyone here, which is whenever I hit a bump or whenever I create a bump, it's because I didn't follow my process. So I'm just going to leave you with that for that slide. Now, how does AI address these points of frustration from this first story that I gave you, that ordinary world? That case where the early stage data collection was essentially open loop, and I didn't have quality measures and all of these ideal things to make sure that we're being very efficient. My number one recommendation is always now at this point, because we have an AI and we create a GUI in a couple hours, and then a few hours after that, we can have a human look at the code. To always have that, always when collecting data, have a data quality indicator. There's this thing, maybe you've heard of it, that it's used in the ham radio world. A 5x5 channel and signal means that the channel, as in the background noise, is low, and the second 5 here is signal quality. So channel and signal quality, have a measure of that. And something I encountered in a project last year was, what would have been really wonderful is to have a targeting system so that we know when our signal is maximized versus, getting something of medium quality. Some kind of targeting, rudimentary targeting built into the GUI would be perfect. And so any project that I would take on in the future would have those components into it. And previously, the activities of synthetic data modeling and simulations were discouraged. Now, if using AI to assist, it's a must-have because it's part of the checking for the correctness of the AI implementations. And it has the benefit of now we can basically build our physics model, right, which is the synthetic data modeling, and see our real data on top of it. So it adds more confidence to the process this year than last year. And one of these other requested activities that I would get from CEOs or stakeholders was making the beautiful plots. Well, that's really easy now with AI. It's a no-brainer. And if one was to just use AI to make beautiful plots and sandbox it in a way that it can't touch any code except your plotting code, it's worth the time. And exporting data and whatnot, very, very helpful. This other part of dealing with clients or when people have different needs for in vitro and in vivo analysis and reporting, again, the AI makes things very easy to customize for different people. So this idea of evaluating multiple mathematical signal and noise models to fit the data. So I mentioned the use of synthetic data. I mentioned looking at the real data. And I mentioned residuals. Well, we now have the ability to analyze multiple sets of equations in a very, very easy manner. And so that's been really useful in my recent work. Let's see. So examples of using AI for creativity and speed. I thought maybe it's useful just to give you some example prompts or just some example things that I've done. Now, I mentioned to you earlier in the presentation that my daughter had created some drawings, and I could just drop those drawings into the Claude terminal, and Claude could read them and do something with it. One of the really wild things I did was I took a picture of a medical device. I dropped that picture into Claude and I said, make this. And it did. It decided to use Python. It created the plotter, all of the things in the correct location, that were on the screen for the medical device. And all it lacked was the input to the plotter for the estimated things from the algorithm. And that was easy enough because I already had this offline code for doing the analysis, acquiring the data from the device. And so connecting the device, the algorithm, the plotter is very, very simple, a no-brainer. So when it comes to demonstrations for stakeholders, we have a demo right there. The other part is customizing GUIs or demos for particular mindsets. We've probably all encountered differences between Android phone versus iPhone users. Well, we can tap into some of the creativity, or you could call it the biases that are built into these AIs, into Claude Code. And I could just say, give me a GUI that would be suitable for an Apple user, an iPhone user, right? Or an Android user. so it'll create that. Another prompt that's been useful is me asking it, based on the synthetic simulation results and the results from the real data, what would you suggest we try next? That's got me unstuck a few times. And we'll get to the questions that that some of you posed in just a moment. One of those questions, though, was about, well, what happened? What about creativity? For me, I'm a very creative person. One of the things that's worked for me is to basically take algorithms and methods from other fields and put them together in new ways. And when I'm stuck, it's really helpful just to have just a little push, even if the AI isn't right, or even if it sort of suggests something that doesn't make a lot of sense given the context. It still provides that little push. And now a bit about privacy. There are various subscriptions to Claude Code, subscription classes. I use a pro version, and I'm no longer hitting limits with what that pro version provides. But it does require that I turn off some settings so that it doesn't retain data for improving their AIs. And that's important for me and for clients, that their data are not being used and will show up in a future AI. There are other companies that have chosen to either not use AI provided by service providers for privacy reasons. And this one particular client I'm thinking of, they do military contract work for the Canadian government. And what they've opted to do was create a large language model and system within their own organization to do that. Okay, but we don't have to be that extreme. There is depends how much you trust these companies. There is a subscription service for enterprise clients that for Claude Code where nothing is retained and nothing has to be turned off. So where does Claude Code fail and where does it work well? These are just a couple small areas I'll give you right now. So I mentioned one of the skills that I have, which is putting multiple algorithms together from different fields to get things to work. And Claude Code isn't very good at doing that. If I ask it to implement, say, an independent component analysis, it can do that. But if I ask it to implement an independent component analysis that first uses wavelet decomposition to create sparsity in the data before doing ICA, it doesn't know about that. So I have to essentially take those two concepts and I can work with the AI to build each of those independently, and then I would have to do the separate ask of, please bring it together, or bring it together myself. Other things that it has done poorly is, again, because I use wavelets a lot, the discrete wavelet transform, like for example, a Debussy's wavelet, is shift invariant. And so there's this extra step of cycle spinning that's used. Now, I noticed that Claude knows what cycle spinning does and will do that. And Gemini will do that too. But it doesn't do it properly. So there is a necessity for checking these things. Another thing that I've encountered is getting Claude to do a fast Fourier transform. Okay, it does that. But then when it comes to for example, addressing the edge effects on a fast Fourier transform, it doesn't consistently apply windowing. And it doesn't, necessarily know what the best windowing would be for the application that you're using. Are you using a flat top window because you have narrowband signals? These sorts of things, these nuances. And so having the senior person and the senior oversight is really important. That hasn't gone away, and it's an absolute necessity to have that because it's easy to go down this path of having this really great looking output that isn't the best output you could get because these nuances are not addressed. Where Claude code works well and where it saved me significant time, I mentioned creating GUIs for sure. Implementing current published gold standard algorithms has been very, very nice. So, for example, a recent client, we're building a new algorithm for new hardware. There is an old way of doing it, and it's useful to benchmark that, compare the old way to the new way. And so the AI has been helpful in doing that. Code translation. I don't do a lot of Python programming. I've done a lot of Octave programming and MATLAB programming because that's where my toolkit is. And I trust that code that I've developed over the years. And so I encountered a situation where now we need to program in Python. Okay, so I started using the AI tool to do my Python programming, and it helped me learn. And it can do translation. Another area I ran into where it became very, very helpful is I have this Octave code and algorithms, and I wanted it to run faster. So I created a set of unit tests for that code, some very, very specific ones based on physics that I don't think an AI or a junior grad student, could get these tests to pass unless the code is implemented correctly. And then I got the AI to create a C version of the code, so it would run more quickly and compile it. It's been very, very useful to use the AI to pull in dependencies for projects and whatnot, and set up projects. In past, I used to spend a lot of time working, on my Ubuntu Linux machine and not having all of the packages there, and having some weird thing go on. So the AI has been very helpful doing that. It creates beautiful plots. I've been able to take plots that I've generated, drop it into the terminal for Claude, and say, "Look at this plot and tell me what you see," or create a mathematical model that approximates the curves on this plot. Let's see, what else? Debugging my code. It's been useful for that. Let's see. Oh, and documentation. That's been very helpful as well. I get these really, really nice, beautiful reports of what I do each day that include the figures and the rationale for why I tried that and what the results were. Yeah, and there are other things in there that have worked well as well. Now, let's just assess what I've covered so far and look at that in the context of the questions that were posed by the team while I was making the presentation. So given what I've said and given what your own experience has been, okay, I'm not going to try and convince you that you should use AI, that you should use it in your process. These are just questions about, do you disagree or agree with these statements? So consider that AI used for product development should be used only for either exploring ideas, either or all of exploring ideas, communicating concepts, creating plots and GUIs, iterating or evaluating product workflows before building the hard stuff, implementing faster code, or just implementing first pass of gold standard algorithms to do comparisons. Do you agree or disagree that you should never use AI for product code? Never use AI in any circumstances where misreporting would break trust or create injury? And this comes to these policies and questions that we'll get to. So one of the questions that I was given was, how does AI impact quality control for regulated development environments? Yeah, so I looked that up, and I'm sure that some of you looked this up as well. And it seems like there's this general statement of any idea explored within the context of developing a medical device has to be documented. Okay, and I thought about sort of a crazy case, which is, well, what if my daughter draws a fox with a collar on it, and I happen to be working on a device for measuring blood flow in the carotid artery, and that gives me the idea that I should, maybe use a collar. Do I have to include my daughter's drawing in the, in the documentation? I don't think so. So this other question then is, if we're using alpha repositories to try out ideas and algorithms and whatnot, is that a bridge far enough away from the product development process for a medical device? And I don't have the answer to that. So that question, I think, sort of needs further consideration in the context. What I do know is that the rules are evolving as things change, and a lot of emphasis is going now towards validation rather than sort of first principles derivation. It's a big topic, and I'm sure there are a lot of comments on that. Let's go to the next question here, which is skipping the human learning, the loss of insights, less learning from failures, and delivering versus discovering. And my experience has been, absolutely, there's a loss of learning if I use AI to do the work for me. If I use AI to do the work for me, I end up in this place where I'm delivering something and I have this question: do I say AI did it, or do I say I did it? And so for me, that test is, if I can say I did it, that also means that I reviewed it, I twiddled the bits and the code and modified things so that I fully understand it. And that's necessary. And I think that's necessary even if, instead of an AI, that we have a co-op student or a grad student who's working with us, who's really awesome and amazing at implementing ideas from papers. They need someone to check the work. Was there a loss of creativity? My creativity increased. There's a recent paper, maybe you've seen it circulating on LinkedIn, where people are saying that creativity overall, let's say overall scientists, if they're all using AI, the creativity would go down. That's because they're all maybe using the same AI, and they're stuck in this sort of AI context bubble. but using it as a way to learn has been very valuable and has improved my creativity. Next question, what areas of the product code benefit most and least from using AI? Well, again, this is a sort of a team decision, or for a team, or the policies or processes that create is what specifically are you going to use AI for, and how are you going to mitigate the risks? And I think I gave some ideas about how to mitigate risks and some conversations to have after this presentation. Question number 4, or statement number 4, no certainty about the outcomes. How do you know that output, suggestion, or code is good enough? It has to be reviewed, always. The tips and tricks on how to go about using AI in code, best practices, and protecting data and privacy. I've covered some of that. And actually, this is another conversation. If you want some help getting started with creating the policies and processes that the team would follow and that the AI would follow and go into the memory file, that's absolutely something I can help with to get you started in a place so that you're not kind of at square one where I started learning, but you're starting a few steps ahead with what I've learned. The sustainable use of AI, I wasn't sure if that question was about the environment and resources and energy consumption, or if it was how to use AI to continue and grow your organization. One of the clear benefits of using AI has been that the AI captures my information and my way of thinking. And if I continuously store that in memory files and whatnot, what I learned was the memory file itself and the context of the AI, I think, is an asset to the company and would remain if I left the company. So that creates this question of, is the AI and the memory file and the context now owned by the company? The digital twin of me that was created through my work process. And finally, the risks of relying on AI as a core part of the company's strategy, what dependencies and losing expertise in programming. That again is a bigger discussion. I think the risks can be mitigated, but again, policies and procedures to keep everyone safe is my response. And that concludes the presentation. I haven't seen any questions pop up in the stream. It's very possible that someone has posted questions and I haven't seen them because of something failing on my end here in terms of my setup. If you do have questions, I'll just go to the beginning of the presentation here. So the website, my own website URL is on that page. Where is that? Wasn't the beginning, right there. At the bottom, kleinzeman.com, my website is on that. Sorry, my email address is on that website. So please send any questions that you do have to that location. Julia.
Yes, thank you so much. I think this has been really insightful. Lots of great ideas and recommendations, and especially thanks for addressing the questions that we had passed on earlier. I mean, I'm happy to open the floor for a few questions. We're a bit over time, but we can maybe stick around for 5 minutes to see if anybody has some questions. I do have a couple as well. So Noah is saying thanks for the presentation. Maybe I can just follow up with one of the questions. So you mentioned that one of the areas where you have noticed AI kind of slip a little bit is kind of nitty-gritty, really detailed information about some complex algorithms.
Yeah.
So I'm wondering, so you were saying that the way to go about it is to just meticulously check everything and review it really closely. But because
Yeah.
it's such detailed information, you have to spend quite a lot of time reviewing. So it's also, from what I know, quite a hassle for you as a programmer to review other people's codes in general.
Yes, it is.
So
Yeah.
does it defeat the purpose at any point? What is your opinion on that?
Yeah. So the cost versus benefit of time and like brain capacity, right?
Mm-hmm.
I don't like reviewing code, and the, you know, to be very frank, sometimes when I review code, I rely on the person who wrote the code that it's correct. I'll just give them the benefit of the doubt, right? And that's a self-preservation, you know, action, because it is hard to review code. And so to reduce that demand, one way to do that is to get the AI to build the, for example, the GUI code, or get it to create the code for plotting, to make beautiful plots, or to get it to create the export code with unit tests, things that are more evident to be correct by what they look like, and have less scrutiny on that. Or to, you know, for example, creating beautiful plots. There are two ways to do that. We can create all the details for the custom code for every single plot, or we can create a template that all our plots use. And so we could create AI to create the template and then use that same code and never have to regenerate it. So there are strategies like that. But absolutely, you're correct. It's coming up with that trade-off between the work to review versus the work to create it ourselves.
Yeah, thanks. I think Noel is also adding some ideas in the chat that he would emphasize tests over reviews, and then he separately mentions that AI produces quite a lot of code to review, and I completely agree with that.
Yeah.
So I don't know if you have any comment on this.
The amount of code that I have a comment. I don't have a solution. Maybe there's a solution in here, which is I've noticed it often creates a lot of extra code that it doesn't need. So like try catch statements, et cetera. For me, when I'm developing algorithms, I want the code to fail for a certain point in the development process. And so all that extra code just adds to confusion, right? And it's not simple. And so I don't know if I put in the memory file, if I ask it to make the code as simple as possible, or as human readable as possible, or various other things, there must be some strategies. But again, relating it to humans, Noel has written code that is like wonderfully pithy, like one line, and it's amazing and it works. But in terms of readability and how to how I could figure out how it works, you know, it was myself and another person that were completely lost, and we're just looking at this going, what the heck?
Yeah, I get that. Okay. Just gonna encourage everyone again to post their questions if they do have them. Maybe the last thing before we close off, if there are no other questions, I wanted to get back to your comments. So you had this slide with statements, whether you agree or not. So I'm wondering where you stand ultimately. So for development of code, production code, especially the type that has, you know, very high stakes attached to it, such as, you know, medical device code that's going to be deployed at a patient's side. Are there any, so would you apply all the same things, or are there any additional safeguards or processes that you would think would be necessary in that context?
Well, Noel made the comment about, I think it was unit tests, and making sure that those are very robust and detailed. But the production code, and again, this comes back to for my kind of rubber stamp of approval to say that this works. It has to be an I did this for me at this point. And I'm not comfortable handing something over that I haven't gone over myself at this point. And that would be the case if I had a co-op or a grad student or a junior working with me as well. I don't want to. I want to absorb the risk myself. And I wouldn't want to pass that on to the CEO who's or the organization that is one day in this high stakes situation and it fails. So fair. Yeah, the production code, it has to be at this point humans looking at that. And I was speaking with another man yesterday who is Chris, actually, Noel, who started Mercurial Communications, and he's of the same perspective as the AI methods for creating prototypes and examples and exploring are really wonderful right now, and production code still needs to be done by humans. Now, does that change tomorrow? I don't know. It's the trustworthiness part of this.
Right. All right. Well, I think in the interest of time, maybe we should wrap it up.
Yeah.
I do think these were incredibly interesting discussions and wonderful insights that you've shared. So again, I guess people are encouraged to reach out to you if they would like to continue these topics and talk to you about any consultation or other opportunities. And yeah, thank you everybody for being here. Thank you, Phil, for putting in amazing presentation.
All right. Bye for now.
Thanks a lot. Bye-bye, everybody.